Cutting glass bottles could be so easy. This time I'll use 3 clever techniques to transform simply glass bottles into eye-catching designs, starting with the most advanced approach and wrapping up with the simplest. I started with a 25mm thick slice of silicate block. I needed to get 2 equal parts, so I marked the middle line and cut with a hacksaw. This material is lightweight and quite brittle, which makes it fairly easy to work with hand tools. Next, I mark the middle once again and offset the ruler a few millimeters on the side. This is a 6mm threaded rod, and it is the perfect tool for the job. By using it as a scraper, I formed a half-round groove along the block. At this point, the threads acted as a file, leaving a perfectly round and even groove. This is a heating element coil wire rated for 2 kilowatts. The formed groove will accept this coil perfectly by keeping it halfway exposed above the surface. As always, I left links in video description for all the main parts used. One last thing with this silicate block, I need to drill a hole at one end, which will help to manage and connect the heating coil later. From plywood leftovers, I started to form a holder for those silicate pieces. CA glue was the right adhesive for the job, allowing me to work very fast and accurately. Its final position should be like this, so by making a few 45 degrees cuts on my table saw, I made a simple holder from a scrap wood piece and glued it in place. The base will be made from this 15mm thick plywood. 2 narrow strips will act as feet by providing a raised surface in between. The second great feature, there will be a perfect guide for my palm router. With a 6mm spiral router bit, I made 2 passes until I milled through the plywood. As a result, I got a groove going through. The base is ready, let's glue in the V-shaped holder. In that milled groove, another sliding holder will be fixed. The process is the same as before. Precut plywood pieces and CA glue make this process relatively fast and easy. This thicker piece should slide inside. Before gluing the second guide rail, I added paper on each side. This will act as a shim and ensures enough space inside when the paper is removed. Nice and smooth. With a homemade router attachment on my table saw, I milled the groove with the same 6mm spiral router bit. I really love the finish which these spiral routers bits gives. I highly recommend you try them out. One more hole was drilled and the holder could be mounted in place. The hardware I'll use includes a square neck carriage bolt, a washer and a wing nut. The square bolt part will sit inside the groove, allowing it to slide and at the same time keeping in place while securing with a wing nut. To keep sliding this newly created part along and parallel to the base, I need to glue a pair of guide rails. I used the same shimmed paper technique because it worked extremely well in my previous glue-up. When the paper was removed, the fitment was spot on. Not too tight, not too loose, and could be moved literally with one finger. Next, I'll use a microwave turntable motor. I salvaged it from an old and broken microwave, but I also will leave a link in the video description if you want to get it online. My plan is to mount it here and at the same time to keep it sliding up and down. I'll use this spacer from the previous glue-up because it has the perfect width. It has enough thickness which allows me to mount motor flush with the surface. A quick job at a drill press by changing various Forstner and regular bits ended up with this recessed part. Now all the hole shapes and depths will start to make sense. The square neck bolt will be placed in the deepest hole. It should sit deep enough to give clearance for microwave motor to be installed flush with the surface. At the moment, one hole is still left unused, but I will come back to it a bit later. Now let's mount the slider in place. The last assembly part, a cone-shaped cork from a wine bottle. No matter the complexity of your projects, custom-made parts are often needed. If you don't have expensive equipment in your workshop, you can always seek this service externally, like from PCBWay. All you have to do is select the service, upload your file, and you'll get the materials to choose from. Just with a few clicks, you will get an instant quote with the pricing upfront. If you are working on projects like me, PCBWay offers a wide range of service that might be helpful. They provide high-quality PCBs, CNC machining, laser cutting, injection molding, and 3D printing from a variety of plastics and even metals. I've used their services several times in the past and had real great experiences. So check out their website in the description below to find out what parts they can make for you. Time to get back to the heating element and the other electric parts. To extend the ends of the heater coil, I'll use those 14 AVG or 2.5 square millimeters of gauge silicone wires. To get a solid connection, I'll use tubular crimp terminals and a crimping tool. I even tried to pull out the coil wire for testing purpose. Trust me, the connection is reliable and very strong. Place silicate blocks into the holder and wired in crimped silicone wires. I chose this type of wires due to its flexibility and great thermal resistance characteristics. It sits quite nicely, but I need to keep the heater coil to follow the groove. I separated one wire strand from a scrap copper wire and adjusted the heater coil position by tensioning it all the way to the bottom. This is important only until the very first heat up. Then the heater coil will lose its memory and springiness. To keep wires nice and tidy, I secured them with wire holders. Drilled a pair of different diameter holes in the base for upcoming wire management. I drilled them at an angle for purpose, which become obvious later. To control the heater coil, I'll use an AC voltage regulator. This is a quite cheap and simple device. A pair of wires goes in, a pair of wires goes out, and the control is done by twisting this big potentiometer knob. Secured the regulator to the base and connected the heater coil wires at the output side. Now it's time to use those drill holes and wire through a pair of wires, a main power wire and a thinner wire to connect the microwave motor. The main power wire already has crimped spade terminals. They are without insulation, so I added heat shrinking tubing and heated up. Now I merged the main power income wire, microwave motor wire, and additional wire splitter with spade terminals. Tubular crimp terminal did the job very well. The second microwave motor wire got a spade terminal and insulation too. To control all electric parts, I'll use this double rocker switch. It has 3 terminals for each button due to the light indication feature. To mount it on the plywood base, I made this simple holder. Managed and connected all spade connectors to the corresponding switch terminals. It is a simple switch, so I don't think that additional comments are needed here. And the wiring job was finished by connecting 2 last wires to the regulator. Proper amount of CA glue fixed the button holder in place permanently. I left with the last unused wire, which is dedicated to the microwave motor. To connect it, I have to remove the motor. The wire was managed through the pre-made hole. Naked wire ends were crimped with a pair of spade terminals. Before connecting them, I made a 90 degrees bend, because inside the plywood holder was a bit of tight fit. To finish, all 4 fixing screws were tightened in. To keep nice wire management under the cover, I used wire clips. I know this part will be not visible, but I like to keep everything nice and tidy. Final check if my wire management isn't too tight in any position. And it is spot on. The final puzzle piece was this Y-shaped plywood holder to catch out all glass parts. And this is it. Let's test this little machine. The first button turns on the motor. The second one gives the power to the AC voltage regulator. By twisting the knob, I adjusted the proper amount of power given to the heater coil. In the current setup, this is how it looks fully heated up. I measured with a power meter that in this setting I'm using only 400 watts. Double switch is great, because it could be turned on and off with a single finger. Okay, let's grab an empty glass bottle and test the performance. Press the bottle on the cone-shaped cork. It has plenty of grip to be turned. Adjusted vertical and horizontal positions to achieve that needed angle and cut length. Flip the first button for the rotation and the second for the heat. I started with the real rotation speed and later speeded up the footage 9 times. About 1 minute later, I grabbed a glass of cold water, dipped the small brush in and with the wet part touched the line which was heated. And it worked magically. I'm not kidding. I was more than surprised by this. Cold, wet touch was giving that thermal shock at the heated line, which caused it to crack. Evenly heated line ended up with a perfectly round and even crack line. It's just insane. I really love those fully adjustable axes, which allows me to cut glass bottles in various shapes, like this. This one was quite thick, but the tool worked flawlessly. You know what is more impressive? That it cuts a glass bottle into rings. It could slice bottle after bottle effortlessly. With a metal ruler, I made small marks every 2 centimeters. This spacing depends on your personal taste, and a bit later you will see how this will impact the final look. When the first line was finished, I rotated the bottle by 90 degrees and repeated all again. After an additional 2 iterations, it should look like this. I would like to form a template by connecting this mark with one step above in the next line. The best material to do that is electric tape. In such a method, I'll go all the way to the top. At the end, I would like to have filled this gap, so let's mark the upper line by starting from this point. And for the finish, rounded both ends. When the template was formed, I grabbed a diamond glass cutter and scored a line around the whole perimeter. Here the crucial moment is to get one strong scored line. If you are hearing similar sound to this, you could be sure that you are doing very well. After this permanent mark was finished, I removed the electric tape and cleaned all black marks. With such result, I'm ready to move on to the next step, to crack the glass along this line. The best tool for this job will be soldering iron with a flat-shaped hot end. By moving back and forward along the line, the heat was evenly transferred to the glass, and eventually the internal thermal stress will crack the glass. In the most cases, the first crack will follow the scored line, but sometimes it could choose another way, as happened for me. Luckily, the crack formed in the part which will be removed later, so I could move on forward and proceed the work with this bottle. The whole idea is that the heat forms the thermal stress along the scored line, and the crack should follow it. The trickiest part was finished. Now I need to remove all that internal spiral part. The easiest way? To split it apart. The right tools for this job are a diamond glass cutter and a soldering iron. From a nut and bamboo stick, I made a simple tool which will help me to remove all glass pieces. And it is time for the most satisfying part. One by one, I knocked out the glass offcuts, and the bottle reveals its final look. Despite the glass splitting very nicely, it still left a sharp edge. So I sanded it with 280 grit sandpaper glued on a small piece of wood. I still cannot decide which part looks better, the offcut or the bottle itself. So, with a few cheap and very basic tools, you could very easily recycle glass bottles for a new life. I'm using regular glass cutter, which you could get from any hardware store. It's neat to make one strong pass all around the bottle. It's important to make only one cut. Don't try to make few passes to get deeper cut. That don't give any better results. Vice versa, it could make multiply splitting lines. Next, prepare some boiling and cold water. The idea is to use physics and let thermostress to do all job. First, heat it and after that very quickly cool down. When heating, it is important to heat evenly as possible all around at cut line. Cold water will make quick thermostress and cut line will crack. In this method, to cut round bottles is very easy, because round bottles have equal surface tension. With square bottles, we have different surface tension at sides and corners, so be ready to fail. Not all square bottles you will try to cut will be done successfully. Even when you did everything right, sometimes you don't get nice cut or get crack where you don't need it. That's because all bottles could have not visible mini cracks and your cut line could change direction. Sometimes you will get only a part of glass off, not full top. Take your time and repeat the process at the rest cut line. At this situation, you could give a light tap to make it done faster. To smooth the edge, I used 60 grit sandpaper and wet sanded to acceptable result. To get nice finished look, I finished with 280 grit sandpaper. And here is final result. No sharp edges, nice and glossy surface. What about propose? Well, it depends only from your imagination. Here are a few examples from me. You could serve some snacks in it, or to store some kitchen tools. It also could be a glass for drink. Leave a comment or just hit like icon if this video was helpful. Don't forget to subscribe for upcoming content. Thanks for watching and until next time.